Our objective in this lesson is to divide radicals. By this time, you are expected to know how to simplify radicals as well as to add, subtract, and multiply them. Remember the conditions for a radical to be in simplest form? Since this video is about dividing radicals, we are going to focus on number 3. No denominator contains a radical sign. Let's have a warm-up first about rationalization. Number 1, 5 over square root of 6. So to what number are we going to multiply this to rationalize our denominator? Since the index here is 2 and the exponent here is 1, we're going to need one more square root of 6. So let's multiply both numerator and denominator by square root of 6. 5 times square root of 6 is 5 times square root of 6. Square root of 6 times square root of 6 is simply 6. Next one. Before multiplying numerator and denominator by square root of 15, let us express square root of 15 as square root of 5 times square root of 3. In this manner, we can cancel square root of 5. So what will be left in the numerator is 1 over square root of 3. So 1 over square root of 3 is much lesser number to deal with. So let's multiply this with square root of 3 over square root of 3. 1 times square root of 3 is square root of 3. And square root of 3 times square root of 3 is 3. Next one, the index is 3 and the exponent of 4 here is 1. So we're going to need 2 more cube root of 4. Let's multiply numerator and denominator by cube root of 4 squared. So 8 times cube root of 4 squared is 8 times cube root of 4 squared. And then here 1 plus 2 is 3. So cube root of 4 cubed. And then 4 squared is equal to 16. In the denominator, the cube root and the exponent 3 will cancel out. So 8 cube root of 16 divided by 4. 8 divided by 4 is 2. So we have 2 cube root of 16. But wait, 16 is 8 times 2. And the cube root of 8 is 2, so let's factor it out. So we have 2 times 2 cube root of 2. And 2 times 2 is equal to 4, so we have 4 cube root of 2. In my last video, multiplying radicals, I have already introduced conjugate. The conjugate eliminates the radical in a binomial. We are going to have some more of conjugate in this lesson. Let's continue. Do you still remember how to form the conjugate of this binomial? Yes, it is the same as this binomial, only different in sign of the second term. So the conjugate of this is 2 minus square root of 6. We are going to multiply both numerator and denominator by that. So 2 times 2 is equal to 4. 2 times negative square root of 6 is minus 2 square root of 6. And then for the denominator, we just have to square the first term, and 2 squared is equal to 4. And then this is always minus, and then square root of 6 squared is 6. We can factor out 2 in our numerator. So 4 divided by 2 is 2. And then copy minus. 2 square root of 6 divided by 2 is square root of 6. The denominator will be negative 2. We can cancel out 2. So we have negative of quantity 2 minus square root of 6. Let's distribute the negative. So this will be negative 2 plus square root of 6. Another one, the conjugate of this is 4 plus square root of 3. Square root of 5 times 4 is 4 square root of 5. Square root of 5 times square root of 3 is square root of 15. For the denominator, 4 squared is equal to 16. And then minus, square root of 3 squared is equal to 3. 15 is 5 times 3, and 16 minus 3 is 13. Before and after plus sign have square root of 5, so we can factor out square root of 5. So what is left here is 4, and then copy plus, and then in here square root of 3 over 13. Another one, the conjugate of this is 2 minus square root of 3. So this is a binomial times a binomial. I'm going to use FOIL method here. 3 times 2 is equal to 6. 3 times negative square root of 3 is minus 3 square root of 3. Negative square root of 6 times 2 is minus 2 square root of 6. Negative square root of 6 times negative square root of 3 is positive square root of 18. For the denominator, 2 squared is equal to 4. and then this is always minus. Square root of 3 squared is 3. We can express 18 as 9 times 2. And then 4 minus 3 is simply 1. The square root of 9 is 3, so let's factor it out. And then we may not write 1 anymore, since there is nothing we can factor out from square root of 3, square root of 6, and square root of 2. This is our final answer. Next one, the conjugate of this is 6 minus square root of 5. 1 times 6 is 6. 1 times negative square root of 5 is negative square root of 5. Negative 2 square root of 5 times 6 is negative 12 square root of 5. Negative 2 square root of 5 times negative square root of 5 is positive 2 square root of 25. For the denominator, 6 squared is 36. Always minus. Square root of 5 squared is 5. Square root of 25 is 5, so let's factor it out. 36 minus 5 is 31, and then we have 6. Since we have invisible 1 here, negative 1 square root of 5 minus 12 square root of 5 is negative 13 square root of 5. 2 times 5 is 10. Copy all over 31. 6 plus 10 is 16, so we have 16 minus 13 square root of 5 over 31. Division of radicals may be classified into two. First, we are going to divide radicals of the same order. In here, we are going to use the property of radical nth root of a over b is equal to nth root of a divided by nth root of b. Number 1, square root of 8 divided by square root of 2. Since the indices are the same, we can combine them into one radical symbol. 8 divided by 2 is equal to 4, and square root of 4 is equal to 2. Next one, again, the indices are the same. Let us combine them into one radical symbol. 192 divided by 3 is 64, and cube root of 64 is equal to 4. Number 3, the indices are the same. Let's combine them into one radical symbol. 162 divided by 2 is 81, and 81 can be expressed as 27 times 3. Cube root of 27 is 3. Let's copy what is left, cube root of 3. Next one, let's combine them into one radical symbol. 4 divided by 2 is 2. Then we have b cancelled out, and then let's copy d squared. Number 5, let's combine them into one radical symbol. 6 divided by 3 is 2, so I have square root of 2 over x. Let me just separate the numerator and the denominator. Let's rationalize this, so we need one more square root of x. Square root of 2 times square root of x is square root of 2x. 1 plus 1 is 2, so I have square root of x squared. And then let's copy square root of 2x. The 2 here and the exponent 2 will cancel out, so over x. Number 6, let's combine them into one radical symbol. 4 divided by 2 is 2. Since this is division, let us subtract the exponents. 2 minus 1 is 1, so we still have 1a. 3 minus 1 is 2, so we have b squared. 4 minus 1 is 3, so we have c cubed. Our index here is 2, so 2 divided by 2 is 1. We can factor out 1b. And also, we can factor out 1c. Let's copy square root of 2a. When we factor out 1b, since this is 1, times 2 is 2, and 2 minus 2 is 0. No more b left in the radicand. But for c, 1 times 2 is 2, and 3 minus 2 is 1, so there is still one more c. Next one, x squared minus 4 is difference of two squares, and it has factors. The factors are x minus 2 and x plus 2. So let me just separate this for you to see it better. So from here, we can cancel out square root of x plus 2. So our final answer is square root of x minus 2. Number 8, the index here is 3 and the exponent is 2. So we need one more p plus q. So let's multiply both numerator and denominator by cube root of p plus q. The indices are the same. We can combine the factors into one radical symbol. I just rearrange them. And then here 2 plus 1 is 3. So we have cube root of p plus q cubed. I hope you still remember your algebra. These are factors of sum of two cubes. So this is cube root of p cubed plus q cubed. For the denominator, the index here 3 and the exponent will cancel out, so over p plus q. This time, we are going to divide radicals with different orders. Here, we are going to rationalize, then convert the numerator to powers with similar exponents. Number 1, let us rationalize this by multiplying numerator and denominator by square root of 2. So this will be cube root of 4 times square root of 2. For the denominator, 1 plus 1 is 2, so square root of 2 squared. And then the index here 2 and the exponent 2 will cancel out, so the denominator will just be 2. Now that we have already rationalized our denominator, let us convert the numerator to powers with similar exponents. But first, let us convert this into exponential form. So cube root of 4 is 4 raised to 1/3. Square root of 2 is 2 raised to 1/2. The objective is to have exponents that are similar fractions, meaning they should have the same denominator. So the technique is just simply determine the LCD. The LCD of 3 and 2 is 6. So 6 divided by 3 is 2. Therefore, I will multiply 1/3 by 2 over 2. Since 2 over 2 is just 1, it will not affect the value of the original fraction, which is 1/3. Now, for 1/2, again, the LCD is 6. 6 divided by 2 is 3. So I will multiply 1/2 by 3 over 3. Once again, 3 over 3 is just 1, so it will not affect the original value of the fraction 1/2. Then let's copy our denominator. Now, 1 times 2 is 2, 3 times 2 is 6, so we have 4 raised to 2 over 6. Here, 1 times 3 is 3, and 2 times 3 is 6, so this is 2 raised to 3 over 6. Now, the denominators of our exponents are alike. They are now similar exponents. Let's copy our denominator. Now, let us convert this into radical form. The 6 will become the index. So, this will be 6th root of 4 squared, 2 cubed. 4 squared is equal to 16. I'll continue here. And 2 cubed is equal to 8. Again, copy the denominator. 16 times 8 is 128. And 128 can be expressed as 64 times 2. The 6th root of 64 is 2. So this will be 2, 6th root of 2 over 2. Let's cancel 2. So our final answer is 6th root of 2. Number 2, let us rationalize this. Our index is 3 and the exponent here is 1. So we need 2 more. So let's multiply numerator and denominator by cube root of 3 squared. 3 squared is equal to 9. So this is square root of 3 times cube root of 9. For the denominator, 1 plus 2 is 3. So cube root of 3 cubed. We can now cancel the index and the exponent here. Our denominator will just be 3. Now, let us convert this into exponential form. Square root of 3 is 3 raised to 1/2. Cube root of 9 is 9 raised to 1/3. But I'll express 9 as 3 squared. In this way, I have the same basis. So let's copy 3 raised to 1/2. And then 2 times 1 is 2 over 3. So this is 3 raised to 2 over 3. Then copy the denominator. Same basis, let's copy the base and then add the exponents. To add the exponents, we need the LCD. The LCD of 2 and 3 is 6. 6 divided by 2 is 3 times 1 is 3. Copy plus. 6 divided by 3 is 2 times 2 is 4. 3 plus 4 is equal to 7. Now I can convert this into radical form. So this will become my index. So it is 6th root of 3 raised to 7. The index is 6 and the exponent here is 7. I can factor out 1, 3. 1 times 6 is 6, and 7 minus 6 is 1, so there is one more 3 inside the radical symbol. I'll cancel 3. Our final answer is 6th root of 3. Number 3, cube root of square root of c all over cube root of c. So first, let us simplify this. Let us multiply the indices. 3 times 2 is 6, so this is 6th root of c over cube root of c. Now let us rationalize. Again, the index is 3. The exponent here is 1. We need 2 more. So let's multiply numerator and denominator by cube root of c squared. So let's copy our numerator, 6th root of c times cube root of c squared. For the denominator, 1 plus 2 is 3, so cube root of c cubed. Now, let's convert this into exponential form. 6th root of c is c raised to 1 over 6. Cube root of c squared is c raised to 2 thirds. For the denominator, cancel the index 3 and the exponent 3, so it will just be c. I have the same bases, so I'll copy the base and then add the exponents. In adding, I'll be needing the LCD. The LCD of 6 and 3 is 6. 6 divided by 6 is 1 times 1 is 1. And then this will be plus 6 divided by 3 is 2 times 2 is 4. 1 plus 4 is equal to 5. I'll convert this now into radical form. This will be my index, 6th root of c to the 5th power over c. Since our exponent here is 5 and it is less than the index, we cannot factor out any c. So this will be our final answer. Number 4, cube root of m squared n divided by 6th root of m cubed n to the 4th. I'll take a little shortcut here. I will make my index the same for both numerator and denominator. To do that, I will convert my index into fractional form. So the index 3 is 1/3 in fractional form, while the index 6 is 1/6. The LCD of 3 and 6 is 6. So I will make one big radical whose index is 6. I hope you still remember our lesson in changing the order of radical. Since I changed my index from 3 to 6, 6 divided by 3 is 2, I will raise everything here in the radicand to the 2nd power. This means multiplying each exponents here by 2. So 2 times 2 is 4, so I have m to the 4th. The exponent of n here is 1. So 1 times 2 is 2. I have n squared. Now, for the denominator, since I did not change the order of my index, I will just copy the radicand. Now, I can simplify this. Since this is division, I will subtract the exponents. So, for m, 4 minus 3 is 1, so there is 1m left in the numerator. For n, since the exponent of the denominator is greater than the numerator, 4 minus 2 is 2. There are 2 n's left in the denominator. We will rationalize this. Since this is 6 and I only have 2, I need 4 more. So I'll multiply both numerator and denominator by 6th root of n to the 4th. Then I'll combine this, 6th root of m n to the 4th. Then this one, 2 plus 4 is equal to 6, so 6th root of n to the 6. And then I can cancel now the index 6 and the exponent 6 here. And then here, I'll just copy the numerator. So the final answer is 6th root of mn to the 4th over n. Another one, the LCD of 7 and 3 is 21. So I'll make one big radical symbol whose index is 21. Then 21 divided by 7 is 3. So I am going to raise everything in the radicand to the 3rd power. That means multiplying each exponents here by 3. So the exponent of a is 1. 1 times 3 is 3. I have a cubed. 5 times 3 is 15. I have b to the 15th power. 8 times 3 is 24. For the denominator, 21 divided by 3 is 7. So I'm going to raise everything in the radicand to the 7th power. 2 times 7 is 14, so I have a to the 14th. 1 times 7 is 7, so b to the 7. 3 times 7 is 21, so c to the 21th power. Then I'll simplify this. I'll subtract the exponent since this is division. The exponent of a in the denominator is greater than the numerator. 14 minus 3 is 11, so there is a to the 11th power in the denominator. For letter B, this is greater than 7. 15 minus 7 is 8, so there is b to the 8 in the numerator. Letter C, 24 is greater than 21. 24 minus 21 is 3, so there is c cubed in the numerator. And then I'm going to rationalize this. This is 21 and I only have 11. This means I need a to the 10th power. So I'll multiply both numerator and denominator by 21th root of a to the 10th. And then I'll combine the numerator. So this is 21th root of a to the 10, b to the 8, c cubed. For the denominator, 11 plus 10 is 21. So 21th root of a to the 21th power. So I'll cancel the index and the exponent. The denominator will just be a. So final answer, 21th root of a to the 10th, b to the 8th, c cubed over a. Quick tips: multiplying a binomial by its conjugate eliminates the radical. Use this strategy when the divisor is a binomial with radical or radicals. Number 2, when dividing radicals with the same indices, combine the radicals, then simplify. Number 3, when dividing radicals with different indices, rationalize the denominator, then convert the radicals to exponential form with exponents that are similar fractions. And again, always express the final answer in simplest form. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Number 1, let us combine them into one radical symbol. C and C will cancel out. 32 divided by 4 is 8. 8 is 4 times 2. The square root of 4 is 2. So our final answer is 2 is square root of 2. Next, the conjugate of this is square root of 3 minus 2. FOIL method, square root of 3 times square root of 3 is 3. Square root of 3 times negative 2 is negative 2 is square root of 3. Negative 5 times square root of 3 is negative 5 is square root of 3. Negative 5 times negative 2 is positive 10. For the denominator, square root of 3 squared is 3, always minus. Then 2 squared is 4. 3 plus 10 is 13. Negative 2 minus 5 is negative 7 is square root of 3. 3 minus 4 is negative 1. So this will be negative times the quantity 13 minus 7 is square root of 3. Let us distribute the negative. So it will be negative 13 plus 7 is square root of 3. Gets?